on, throw! Got him! Got him again! What I just played for you there were several examples of a catcher throwing from home plate to second base when a runner in a baseball game is trying to get from first base to second base without getting caught. And that, as you noticed in the video, many times the runner was out. So what I have for you here is an example of a word problem that would apply that situation that you just saw in the video there. Take a look here on this word problem sheet. If you don't have this sheet in front of you, please pause the video, come and get the sheet from me, and get started with the assignment. And what we're going to do is I'm going to go through these very quick, these problems with you, and we'll take a look at them. But number one here is a baseball problem, just like what I had in the video. A baseball diamond is a square. Each base path is 90 feet long. So when they're saying 90 feet long, what they're talking about then is they are talking about, let's see, I need my pen, need my pen, need my pen. Okay, here we go. They are talking about the distance from home plate to first, that's 90 feet. From first to second, 90 feet. Second to third, 90 feet. And third to home is 90 feet. So what do we do with all those numbers? Well, let's take a look here. It says each base path, go back to the beginning of the problem. Each base path is 90 feet long. After a pitch, the catcher quickly throws the ball from home plate to a teammate standing by second base, which you saw. Find the distance the ball travels. Round your answer to the nearest tenth. Find the distance the ball travels. All right, so this is what we got to find. Find the distance the ball travels. Okay, if you take a look at the shape here, notice they have a dotted line drawn from home plate out to second base. If you take this line right here from home plate to second base, let's take a look here at this now. We have this from here to here is what we're looking at. And notice, what do you see here? Home plate to first base, what does that form? And then from first base over to second base, notice we have a triangle, and it is a right triangle. Now, how are we going to solve this? Well, this is Pythagorean theorem. Anytime you have a right triangle, the right angle is right here at first base. That's right here. So you are now given the two shorter sides. You have to find the longer side. So again, I'm going to use Pythagorean theorem of a squared plus b squared equals c squared. So I'd like for you to fill in this case, you've been given the two shorter sides. So where do those go? That's for A, and that's for B. And you're going to have to calculate that hypotenuse length, just like you were doing in your last book assignment. Okay, I would pause the video at this point, and I would now do this problem right here, the baseball problem. All right, now that you've paused the video, let's move on here. Let's take a look now at problem 2. See if I can get a hold of this to slide like I need it to. Got my select key going here. All right, up we go, down we go. Come on. There we go. It's like the ink stays in the way, so I will clear that out of there. Let's look at number 2. Triangles. Each student in Mrs. Kelly's geometry class constructed a unique right triangle. Let's see, where's my question here? You know, instead of reading it from the beginning, let me give you one of the things I like to do when I'm reading word problems is I want to go down and find out what am I supposed to figure out. So let's take a look in here. Let me get a pen in here. And let's get a nice thick line. All right, so usually, and you'll find this in test questions, and you'll find it here in the worksheet. It says, here's my question, which result was recorded incorrectly? So what am I supposed to figure out? Which result was recorded incorrectly? All right, so let's go back through our information. Each student in Mrs. Kelly's geometry class constructed a unique right triangle from drinking straws. Mrs. Kelly made a chart with the dimensions of each triangle. However, Mrs. Kelly made a mistake when recording the results. Which result was recorded incorrectly? What do they want us to do here? We've got sides A, B, C, and she's recorded some numbers here. All right, Pythagorean theorem. Pythagorean theorem basically says this, again, a squared plus b squared equals c squared. All right, when you're given all three lengths, Here's how it works. They want us to find something that was recorded incorrectly. So let's take a look here. We'll do Amy's right here. So I'll do Amy's. So we have 3 squared. This is what I'm going to put in for A. I'm actually going to put in 4 for B. So 4 squared. And then equals, since I was given C as 5, I'm going to say 5 squared. And now I'm just going to calculate this. What is 3 squared? Well, 3 squared is 9. 4 times 4 is 16. And 5 squared is 25. Okay, so this is Amy what we're doing here. And I'm going to label this. So Amy, we got my Pythagorean theorem. I filled in. I've started my calculations. 9 plus 16. If you add that together, it's 25. Use a calculator if you need to when you're doing your work here. And that says it equals 25. Is that true? Yes, it is. So that means Amy's numbers are correct. Because if you have a right triangle and you substitute into the Pythagorean theorem, you will get an answer looking just like this. The number equaling itself. And when you get that, that's a true statement. That means Mrs. Kelly recorded things correctly. There are 4 of them left to do. You need to substitute those into the Pythagorean theorem. What you are looking for is something that might look like this. 48 equals 49. That's false. So if you get something that looks like this is incorrect. This is where her mistake was. And if you find that one, you can certainly stop there. So this is what you're looking for. So on your paper, you want to kind of do it like I did. Label the name, substitute into the formula, do the calculations. If you get a number equals a number, hey, that's a right triangle. You know that. If you get something where the numbers are different, that isn't a right triangle. All right, pause the video here. Take a look at Belinda, Emery, Fran, and Gus and figure out which one's incorrect. All right, next we're going to move to problem 3. Let's take a look at problem 3. Oh, my ink stays. I got to erase it. Got to erase my ink. Let's see. Clear my ink. Okay, problem 3 here. All right, this is actually on a map, and they'll do this on maps. They'll try to find the distance between a couple of different points. We're supposed to, let's find that distance between Macon and Berryville. Round your answer to the nearest tenth. All right, when they are trying to find distance on maps, they'll actually lay a grid over the top of it just like this. They'll lay a coordinate plane right on top, and they're going to draw a line between the places they're trying to find a distance from. So that's between Macon. So Macon's right here, and Berryville is right here. Well, this one, notice it goes diagonal. Of course, in a worksheet, they're going to try to set up a problem for you like that. That's going to go diagonal, so you're not going to be able to just count it. Now, as you look here, we're using the Pythagorean theorem. We're looking for right triangles. If I go across the top over to Hamilton, oh, that's not directly above Berryville, is it? So let's see here. What would we do? Well, sometimes you create the right triangle. So let's take a look here. Can I create one? Let's draw a line from Macon. Let's go straight down until we're across from Berryville. So on your paper right now, I would draw a line here like this. And then I'm going to draw a line right here going straight over. Now, does that create a right triangle? Kind of looks like it, doesn't it? If I go straight to this point and then straight over, it looks those are perpendicular lines. So I have a right triangle right here. Now, what can you do with these spaces? You've got a space here, and a space here. How many miles? Let's look at our heading here. It says tens of miles. So let's see, I count 1, 2, 3 spaces. If I count 3 spaces and this says tens of miles, all right, then this will be 30. That means it's 30 miles from Macon down straight to here till I'm directly across from Berryville. You want to use this same idea to count the spaces and count the number of miles from this corner all the way over to Berryville. So there's 1, 2, 3, 4, 5, 6, and 7 spaces. So let's look at our heading down here. Our heading down here also says tens of miles. So if there's 7 spaces and each space represents 10 miles, you tell me how many miles would that be down here. Now, once you have that in there, you have the 2 sides that make up the right angle. That means you've been given the legs. It's time for you to take this over a little bit. Which 2 sides have you been given? Remember, you have A, B, and C. A and B are the legs, C is the hypotenuse. So you've been given 2 of the 3 sides now. You want to fill that in. You can probably write this over here in the worksheet, or actually probably down at the bottom if you'd like. There's probably some space there for you. But again, you're using A squared plus b squared equals c squared. All right, and I helped you calculate a. A is going to be 30. And I told you a little hint about this one here. Notice it's on the side, so you've been given the legs. You're going to have to figure out the number here, calculate the hypotenuse. When you get done with that, notice they said round your answer to the nearest tenth. So that means something like this, 102.4. So you want one digit after the decimal point. All right, pause the video here, calculate this problem, get her done, and then we'll move on to the next problem. Fantastic, you've got that calculated. Now, if you need to check your answers while you're doing this, come and get the answer sheet from me, and we will definitely check and see how you're doing. If you're not doing okay, then we want to take a look at your work, and then we'll figure out what we can make better. All right, the last problem I want you to do actually is number 4, and this is an application, believe it or not. If you go home and you measure a television set, this is how they measure when you walk into a shop and you see that great big 60-inch television on sale for whatever the price might be. Well, the 60 inches isn't how tall it is. It is not how long it is. It's actually the diagonal. They measure it from corner to corner. Corner to corner is how they actually measure. So when you see any ad, or you walk into a Best Buy or Target or Walmart, and you go into those places and they say, this TV is a 42-inch TV or a 50-inch TV, they are measuring corner to corner. That's how they're measuring it. So what we're going to do here, we'll practice. This is actually a problem they are going to actually give you the TV size, which happens to be the measurement from corner to corner. And then they're going to give you the width. And we're supposed to find the height. So this is actually going to be a problem where you will be looking at the Pythagorean theorem and you've been given the hypotenuse. So here, let's read our problem here. It says complete. Let's go down to my chart. Looks like I got an empty chart, and I'm going to start right here. Let's take a look here to read what we're supposed to do before we go up any further. Complete the chart to find the screen height of each television given its size and screen width. Round your answers to the nearest whole number, So that means we want no decimal points. Everything's going to be a whole number like what you see here in the width column. Okay, so televisions are identified, back to the top. Televisions are identified by the diagonal measurement of the viewing screen. For example, a 27-inch television has a diagonal screen measurement of 27 inches. Okay, so let's see what we're doing here. Let's see here. I have a 19-inch size TV. Now what that means is this. So if I want to look at my picture here, I want to look right on my picture, a 19-inch means this dimension right here, the diagonal to diagonal is 19. The width is 15. That means they're telling you that this dimension here is 15, and we have to find the height. The height is right here. All right, so now, what do you notice right here? This is a square corner, so that's a perpendicular corner. It's a right angle. I have been given the longest side and one of the two shorter sides or one of the two legs. So how do I write this? Well, if I'm you're going to put this on a sheet of paper. I would copy this chart over to a sheet of paper, okay? I'd copy it. Copy the chart to paper. If you'd like, but you will definitely need to do your work on paper. How would I do my work? Well, notice I'm always after the height. So I am going to use h this time because I want the height. I want my letter to work with the Pythagorean theorem. I'm actually going to know that the height squared plus, and I've got 15 squared equals 19 squared. All right. Some of you might say, why are we going to do this? I can just look in the box and find the dimensions. Yeah, you probably could. But so what is it for then? Well, it's to practice 4 times. How do I find the length of a missing leg? So it's working with the square roots again, working with your equation work. That's all it is. But to show you this is true, this is how they measure a television. So you want to take your calculator and do 15 squared and do 19 squared. Now, where's my calculator? There it is. So I'm going to clear it out. And I want to do 15 times 15 because I am doing those squared. So I'm going to say h squared plus 225. Oh, mistake. Where's my eraser? There we go. Get my pen back, my nice red one. I want that. Yep, there we go. So I have 225 And that's going to equal 19 squared. So I'm going to do 19 times 19. That is 361. And how am I going to calculate for this height now? Got to get that h by itself. So on both sides, I want to subtract 225 off of both. Oops, a minus sign there. We got to erase again. There we go. All right, so I'm going to subtract 225 off of there. Need my marker back. All right, here we go. Minus 225. So then, h squared equals 361 minus 225. Let's see. I'm going to borrow here, 5 and a 1. So now I have 136. And now I want to do the square root. So h equals the square root of 136. So h is going to be about, and I'm going to take my calculator and clear it out, and I'm going to type 136 and find the square root. Remember, some of your calculators, you may have to press the square root function first and then enter the number. This one happens to use, I have to type the number first and then hit the square root symbol. It's just the way the calculator is programmed. We were told the nearest whole number, so 11.66, that is going to be rounded to a 12. So then in my chart, I'm going to put a 12 here. It's approximately 12. All right, there's 3 more left for you to do. When you finish problem 4, check all your answers. Be sure to check all your answers so we know how you're doing on. If you're not doing okay, we got to figure out what we're going to make better, how to make it improved. If you're doing great, got the answers correct, turn it into the front table. You do not need to do problems 5 and 6. Just problems 1, 2, 3, and 4. All right, keep going. Turn this in when you get done. Be sure to check your answers.